Well, thank you for the kind introduction, Lisa. That was lovely. So just to introduce myself to everybody who's joined, my name is Duncan McKendrick. I'm a senior technical account engineer here at Sumo Logic. I've been working in the observability space now for almost 6 years. And to be honest, I really like it because I think it's a very interesting area to work in. So what I'll be presenting the brown bag on today for you all is reducing your MTTD or mean time to detection and your MTTR mean time to resolution, basically to improve customer experience and also the business value aside from that, because the longer it takes you to find, locate, investigate, and resolve issues, the larger the cost is to your business effectively. So basically in reducing these two core metrics, we hope to bring down those costs for you. So observability and why Sumo Logic. For that, we have a platform which consumes a number of things and it allows you to monitor and detect issues, investigate and resolve those issues. And also, once you're in a more stable, more mature position, it allows you to also prevent those issues. And that can happen all in one place, and that place is Sumo Logic. So the agenda for today's call is essentially what I want to talk about are the I'm going to cover a bit of theory around observability first. I apologize to everybody who's not really into theory, but I think it helps really paint the picture of what it is, why we use it, and how it can help you. So for that, I'm going to discuss the core pillars of observability, what observability is, and then we'll move into how we can use those, and that's essentially in defining what the metrics are we're going to be looking at today. So that's MTTR and MTTD. And then moving into the golden signals. We're going to start at the basics together. And then effectively, I'm going to do a demonstration for you today in creating monitors in Sumo Logic. And then another demonstration following on from that in basically a real life or almost real life, slightly staged use case of a detection, an issue being detected, going in and resolving that issue. So thank you very much for joining. And we'll start with the core pillars. So the core pillars of observability are logs, metrics, and traces. So just to give some information on each of these items. So a log essentially is it's data produced by your application or your infrastructure, typically stored in the format of a log file. You're looking at unstructured or structured data. These can be events, they can be errors, they can be request data. So people making requests and and your system basically logging the fact requests are happening. Developers can be using these to help debug their applications if they need to. So it might be that you have debug logs, there's info logs, and there's different levels of logs that you can use, but they provide quite a lot of insight, a lot of information about what's actually going on in your application or your infrastructure. Metrics, this is the oldest of the pillars, the granddaddy of the pillars, as I like to call it. So what this essentially is a metric is a numeric value that's assigned a name. So kind of like a key value pair. Although currently metrics have become more complex, there are dimensions to them, which is effectively just more metrics of the same metric of different values. But really it's a numerical value with a name, such as CPU usage of your server or memory usage of your server, or potentially how many requests you've got going into your application. The amount of 500 errors, the amount of 404 errors. That's essentially what a metric is. Traces are the new guy on the block. So traces are more for the APM side of observability, so looking from the inside of your application. And they typically represent kind of key actions that might represent the workflow or the flow of your application. So for example, if you've got an e-commerce website or something like that, that could be the user logging into the website. It could be them searching for a product. It could be them adding that product to a basket, going to the checkout, making a payment. So these are the things that would be a trace. They're kind of that workflow. It does operate in an autonomous application as well. So that there would be like getting information from queues, etc. Now, they were originally people would talk about trace and they'll say it's for distributed systems. Now, I do personally, and I've put as a note on here that I think they work perfectly well in a monolith as well. So if your application is a monolith, tracing would still work on it because it would still give you insights into like that key workflow that users are doing, and you can see potentially where the problem is. Traces are also made up of spans. So in essence, they're kind of like a log from inside the application. They're made up of a span. Multiple spans can make up a trace. That can be, for instance, a call to a database server or a call to another service, and that they can show where that potential problem sits in that trace. So for example, user goes to log in, the login fails, not because of their password or anything, but there might be a deadlock on your database with the user details in it. Just an example. So these are the core pillars of observability. And how do they come together? Well, they all come together to make up what is known as observability. And what observability is essentially it provides you with the data needed to kind of see from an external point of view what's actually going on internally within your application. Now, metrics could be more seen on the outside of that. They are more of an external bit of data. But logs and tracing, they definitely provide insights that for the internal workings and mechanisms that make up your applications or infrastructure. So the data this provides you with allows you to investigate, detect, and resolve problems. It also provides you with the data, as I said earlier, to proactively work on preventing such situations from happening in the first place. Once you become more mature, you can build structures into Sumo Logic, which will help prevent things from happening in the future. So where does that take us? Well, that takes us to the two key terms that are kind of around this brown bag, and that's your mean time to detection and your mean time to resolution. So the mean time to detection is essentially how long it takes you to find the problem. Now, one of the beautiful things about Sumo Logic here is that sending your log data, your metric data, your trace data into Sumo Logic allows Sumo Logic to notify you when there's a problem, which is brilliant. And it can pretty much point you to where to look. So that is automatically reduced by having the tool of Sumo Logic. Mean time to resolution. This is the time on average it takes you to resolve an ongoing issue. And these two metrics are two things that you could probably track as a team, as a business, because they're really good things to track. As you improve, you will see them come down and reduce, which means you're giving your users a better experience. Because if I log onto a system and it doesn't work, I'm having a bad experience. But if it's being quickly resolved by the teams or prevented by the teams, in that situation, I'm in a good place as a user. So how can we put all this together, and where do we start? Like if I'm new to observability, if I'm new to Sumo Logic, how do I put all of this together, and where do I start? I can hear you asking me, like, but what do I do? What's my next steps? Like I have all this I have all this information going to Sumo Logic, but what do I do with it? So for that, we're going to start at the basics. And the basics for observability are essentially the four golden signals. You might have heard the term before, but it's quite well known. And these four signals basically represent the core parts to understanding how your system's working. So starting from the top left and then moving down to error rates, let's take a look at what these are. So we have saturation. Saturation is kind of a look at your infrastructure. That being if you're running in a cloud native Kubernetes environment, or if you're still running bare metal servers in a server farm, you're kind of going to have saturation metrics. They're going to be your CPU percentage used or your CPU usage. It doesn't necessarily have to be a percentage. Memory usage of your servers, input output streams of your servers, all those kind of things where bottlenecks can occur. The next on this list is load. Now, load is also referred to in some cases as traffic. So don't get confused. It basically means the same thing: requests, traffic, load. And this would be requests going into your system. So users using your system, and they're going to be busy periods that you're going to know to expect to scale up or anything like that. And they're going to be unexpected busy periods. So just thinking in recent memory, we've recently had Black Friday. We've recently had Cyber Monday. And pretty much as I heard on the radio today while picking up my toddler from nursery, we have got, in the UK at least, Amazon last minute deals, which I assume is going to force more traffic to Amazon. So in that note, they're going to be expecting more load and more users. In events like Black Friday and Cyber Monday, you can prepare for it. You can scale your application so that it's ready to handle this new user load. However, in some scenarios, you might not be ready. Maybe marketing releases a new product and that video goes viral on TikTok and everyone comes to your e-commerce site desperate to buy that product and it crashes because marketing never let IT know that that was going to happen. When you get lots of requests, it's also going to increase your saturation, by the way. So your memory usage is going to go up, your CPU usage is going up, which is kind of how these golden signals are effectively related to one another. The next is latency. Latency is effectively the response time of your application, of your servers, of your processes, etc., how long they're taking to respond. And once again, you're going to be paying attention to if this is getting higher. So for instance, once again, going back to that load, that traffic and saturation, the higher your traffic and the higher saturated your systems are, the likelihood is it's going to be responding slower. It also could be bound to down to a bad upgrade or an update that you've made to your software. It might be less efficient than it was before, and you will see your latency go up. You might want to be notified to let developers know that potentially they need to revert back or the change needs to be made to improve performance. And finally, we come to error rates. Error rates kind of cover all of these things. You're likely to see more higher latency. You're like to see error rates also occur when saturation is high and also load is high. But once again, could be down to an upgrade or a change to your software or a database change or something that could be causing the errors. Typically, this is how you monitor your app availability. Is your app down? Is your app up? So for that, you're going to be looking, many teams I've worked with, because my background was in professional services, a lot of teams would typically work on 500 internal server errors being the error rates that count versus normal requests. And obviously users aren't going to want to see error rates. If they're hitting error pages, they're likely to go to a competitor. The same goes for latency, by the way. And I think we're all guilty of this. If a page takes longer to load than you're expecting, the likelihood is you're going to just jump over to a competitor, watch the video there, or buy the product from them if it's a similar price. Now, there is one thing that we can't predict. There is something that I like to refer to as, I'm going to refer to as now as the singularity event. And this event you can't predict. This event can happen to anybody. Let's say you're a ticket website and then a huge artist decides at that moment she's going to basically go, oh, I'm going to do a new tour. Your ticket website is not going to handle the Swiftie traffic. But using these 4 golden signals, you can at least react to the Swiftie traffic. I'm going to call this the Swiftie effect. Effectively, Taylor Swift can bring down IT systems if she so chooses by just starting a tour or saying she's going to do a gig somewhere. That includes merchandise, like literally merchandise sites will struggle as well. So you can prepare for that, but you have no guarantee when she's going to announce her next tour. So the next question I hear you ask is, well, Duncan, we've covered the basics. We've also covered Swifties. How do we actually do this? What do I have to do in Sumo Logic to achieve these goals? How do I reduce my MTTD using monitors? How do I then use the monitors to reduce my MTTR and my MTTI, which I haven't mentioned? That's the mean time of investigation, by the way. So I'm going to do a demo now. So we're going to go down the rabbit hole and see how deep it goes. So in Sumo Logic, I'm assuming everybody has at least seen the interface once before. Here it is. So what we want to do is from the left-hand menu is navigate to the alert section here, where we have our alerts, and then we're going to nip over to monitors. Now, what I want to do is we're going to create 2 monitors based on 2 of those golden signals, and we're going to do it kind of together at this point, and I'll walk you through the process of what information you're going to probably want to use depending on your application, etc. So, provided you've got the correct permissions to actually go in and add a monitor, you would go in here and go add new folder to organize it and then add new monitor. So what I'm going to do here is I'm just going to nip over to DM monitors, a folder I created earlier, by the way, in classic Blue Peter style, for those Brits on the call, if there are any Brits on the call. So here we'll just click add and then we'll go to new monitor. And this gives us the new monitor interface, which actually it's quite a nice interface. It's pretty straightforward to use, and I'm just going to cover each of the core terms in here as we go. So the first is trigger conditions. What's the trigger for our event here? What's going to trigger it? Now we've got two monitor types that fit into these conditions. You've got logs and you've got metrics. There is a third type, by the way, that I don't see because I don't have permissions for it in our demo site. And that is SLOs. Now, I don't have time to cover SLOs today, but I would love to in future because I think they fit into observability fabulously. I think they do a great job in maintaining certain things. So that's definitely worth a conversation to have with everybody in the future. But for now, let's look at logs and metrics. So if we choose logs or metrics, you get your area to put your query in here. So essentially, you've got your log query or your metric query. The next is detection method. So we have static. Static requires you to kind of know a threshold that you're going to want in future. I do recommend that teams do come up with these. For instance, you can come up with some quite basic ones. If you own, say, the search service of your business, it might be that you want a search to return results within 1 second. That can be your threshold for at least warning. And then if it goes over 2 seconds, for example, that can be your threshold for critical. They're the types of things that you want to think about. You can use anomaly, and anomaly does use our machine learning AI to kind of learn based on the data set you've got of how that data looks over time, little wiggly line, and it will alert you based on that data. So what we can do is we can set our anomaly to basically if all of the data is above a certain point, above what's expected, you can use the anomaly detection would alert you at the point you're above that line. You can also do down below. But for example of requests or load single golden signal, you're probably going to want to use both because actually the indication of your load going down indicates that your site's inaccessible or your application's inaccessible. That being an internal application like CRM that you might be monitoring, or as I've kind of flogged to death on this call, an e-commerce website, such as a ticket site. So that would be using both. Then you do have outlier as well. But for today's call, we're going to focus on static. We're going to keep to the basics here. So what do we need to do here? The first would be a query. Once you've got your log query, and log queries can change over time, it might be that you experiment with your query in a log search to begin with before migrating it over to your monitor. Then that's exactly what I did in the examples we're going to be using today. We have what it triggers on, so what column, what data set it's going to trigger on based on our query. We then have our alert grouping. Now, this is quite important, and I'll cover it in an example shortly. But alert grouping, you have one per monitor, or you can do one alert per. So let's say you bring back a list of IP addresses as a count of IP addresses for your EC2 instances, etc. And how many calls have been going to each of those IP addresses. And if one of those IP addresses has got too many calls, or one of those EC2 instances has got too many calls, you might want to only alert for that particular instance, not for all of them. That's where you'd group by one alert per, and you'd use your column that you've brought back in your query. We'll see it in a moment. And then we come to trigger type. Trigger type is where we have what to do in the event of a warning, which is your threshold for warning, what to do in the event of a critical, and if there's no data returned, what to do. Once again, this is quite a good one for app availability, because if there's no data, then it's likely that your app is down, or unfortunately it doesn't have an internet connection to be sending data to Sumo. But the likelihood is your app's down, so you're going to want to know about it. We follow that down. There are some advanced settings. So in the advanced settings menu, we have use alert group monitor name. That's the monitor name we're going to give it at the bottom here, such as test monitor. My imagination is so great. Test monitor, but then we could customize that in future. And I'm going to show you how in another Blue Peter special in a moment. Then we have notifications. Do you want to notify people that this event has happened? And we have multiple notifications types. So you can do the most basic, let's send an email via SMTP. Or you can do a webhook, which is essentially a API integration with a number of services, or you can just define your own webhook if you have an API that you want to call to and you know the format of the data that you're going to be sending. If it's JSON, it's really quite easy to set up your own. So you can go in here, you can set a connection type. So for instance, you could send information to Slack, to Teams, MS Teams, or even you can create Jira tickets, etc., out of these notifications. Then we have playbooks. The playbook section is effectively where, say you were the owner of the system and you know if the latency of your infrastructure, if certain parts of the infrastructure has gone up, it's likely to be a CPU or memory problem. It could be that you guide the on-call member of staff or the person who's dealing with this alert into the relevant dashboards within Sumo Logic into what to use. So they can essentially follow these steps that you've given them and they can quickly resolve the issue, or quickly identify and resolve the issue. Then we have automated playbooks. Unfortunately, again, this is another topic I would love to spend ages talking to you. And as you've probably guessed already, I can talk for England. So I'm not going to bore you with it now, but automated playbooks is definitely another point of interest. Now, this is new to the core product. It came from SOAR, it's in SIM, and it's now in the core log analytics product as well, where you can run automated playbooks. So that's taking a lot of the manual steps out of it, but you can still include manual steps and it will do stuff. So for instance, if your load has increased significantly, your saturation has increased, and if you're in like a cloud native Kubernetes environment, at that point, you might want to scale up, but you could have the system do it for you based on certain criteria, and that could all be done in an automated playbook. Monitor details, once again, here's the name, the folder it's in, so DM monitors. Once again, really imaginative. You can add tags. So your tags can basically describe your monitor. So if you're looking for particular monitors within your system, it could be you don't know the name, but you know it's going to be on AWS EC2, and then you might filter it better, and then you can give a description. So just on the consciousness of time passing here, I have done once again another classic Britishism, Blue Peter style. Here's two alerts I made earlier. So I've done one for Apache error rate monitor using log data, and I've done one for what is our demo application, a coffee bar application for latency using metrics. So for this one, let's just take a quick look. So our trigger condition is logs, and here is my query. So what I'm doing here is I'm pulling all of my Apache data and checking it's got a status code. From that point on, I basically count all of my 500s, or I create a new column in Sumo Logic for the 500s. Basically mark it as a 1 or a 0. And then we sum those errors up as error sum column, and I add all of the calls together. So basically we're getting a count of every request that we've had, no matter what the status code is. And we're also getting a sum of all of our errors. And then I just do a classic division to give myself a percentage, remove the other fields, and here we go. So we can trigger our alert on the percentage field, which is what I'm doing. And then Sumo Logic gives us a lovely little graph. I haven't set a warning, by the way. Now, this is not something I recommend. I do recommend people set warnings because they do tell you, it's like a preemptive thing. It allows you to kind of start setting up rather than a critical, which is potentially there's actually an ongoing issue. So what I'm doing here is I'm alerting if 10% of my requests are errors. As you can see, I'm pretty well below that 10% line, and this is where I'm going to show you another line to my query. So I've worked with many teams building observability monitoring, and one of the things that I've always done this version, but one thing that I've come across with a number of development teams is they prefer to keep it to like, we want 99% of our requests to be good. And that's how they build their monitors. They build it the opposite way round. And that's where this line comes in. So just to show you what this does, if I just comment this one out and bring this one to life, we have a 100 minus our 10%, or a 100 minus our percentage. So if I just press enter here, we get the opposite view once that loads. So we'll change this to be less than, so if it's less than 99, there we go. So this is basically that there's not much leeway in here for errors anymore, by the way. I need 99% good transactions or more. But this version is basically saying if it's less than 99, if my requests are bad, well, if my requests are not healthy, 99 or more, times, then it's going to alert. So that's one way to do it. But I'm going to go back to the easier way to explain now, and just comment out this one and switch that back to 10. Greater than, there we go, and press enter. So in the advanced settings, I haven't really done anything here, but just to show you some stuff, we do include variables. So if you were to be alerting off one of the subtypes that you might bring back different time series graphs here, it could be that you want to customize the name to be relevant to that. So you could say alert on, and instead of saying X service, which you'd then have to manually create an alert for each of those services, if we're doing that group by function, instead of the X, what I can do is I'm going to be slightly cheeky here because I can't remember the exact format. We're going to steal this one, results.json field name. Now, instead of the X, I'm going to pop that in and just change my field name to be, so I can't think of anything else at the moment, source category. So if I had multiple source categories coming back, this would then pick the, so if I had source category as one of my fields, it would then allow this alert to kind of dynamically be named. These can also be used in the notification that you send out. So if you want to customize your Slack alert, if you're going to send to Slack or your Jira, anything like that, you can use these custom types in here. So for instance, I'm using trigger type. It says monitor alert trigger type on alert name. You can use these variables in here. The one thing that I haven't mentioned, actually thinking about it, and I didn't mention earlier, is the trigger type here. We can auto resolve issues. So in the event where you've basically done the work of the investigation, you've applied your fixes, instead of having to manually stop the alert in Sumo Logic, it can recover itself based on data. So you can go edit recovery settings, recover automatically when that meets that and it fits your criteria. And you can also have a recovery response as well to let people know that the alert's recovered. So I didn't actually add a playbook into my demo, but the automated playbooks can allow better notifications as well, by the way, because you can add some logic to it. You can say if it's a recovery, this is the email that I want to send. If it's a new critical alert, this is the one I want to send, or you can hook it into other systems. So coming out of that, that's the log example. I won't save any of my changes. So we'll come to coffee bar latency. Now I could have also done this using log data as well, but I chose I wanted to show the other type of trigger type, which is metrics. And here we go. So we have query, we've got query A, and we have service latency, which by the way is a metric created from tracing. So just so that people know you can alert from trace data. We create a number of metrics off the back of it. We've got service latency, service operation latency, service errors, service operation errors, service requests. I could go on. And they've got dimensions to them as well, which allow you, if you are using the tracing part of Sumo Logic, you can do dynamic alerts off those, by the way. So here we have one query, and you are allowed multiple queries in a metric monitor. And that can work in certain ways, because it might be that, like my previous example where I was doing errors divided by total number of requests, if I have multiple metrics, if I have a metric for application errors, and if I have a metric for application requests, it could be that I bring back the total requests here and then the errors metric here, and then I do a C query, and that C query could be that division that I did in the percentage calculation I did previously, and then that's the metric that we use going forward. So you can use multiple metrics in here, but just to not confuse people, I'm just going to leave it as it is. Once again, you've got one alert per monitor, but in this case, we could go one alert per service, because as I said, there's multiple dimensions in trace data. And then you can do one alert per time series, which is more or less one alert per service if I had multiple services coming back here. And then pretty much all of the settings are the same. You've got your playbook, you've got your monitor details. I've given this one a name and a description, by the way. And this did actually alert me today because I did actually set it up more realistically compared to my previous version of 100 milliseconds being my response time that I was happy with. That is still quite quick though. But once again, anecdotally, I have worked with a team once who needed something to respond in quicker than 10 milliseconds, which is really hard to monitor and does cause alert fatigue. So something to bear in mind. Think intelligently about your thresholds. Don't, because you don't. One of the things we provide here is a fantastic tool, but the thresholds are quite important. But that's where anomaly detection can really come in, because anomaly detection, you can actually kind of come in and configure how many alerts you might want to see. So shall we see this in action? So we see what monitoring looks like and how it can help resolve?
Yes.
So here we go. Here's an alert I had earlier, and it is for the coffee app. So once again, this alert's using a webhook functionality and going into Slack. So we have critical alert, coffee prep time increase, and we can see the latency was greater than 1.5 in the last 5 minutes. So it's monitoring a 5-minute period. And this is the query it uses. But if I follow this alert URL here, this is going to take me into Sumo Logic, and it's going to take me to the alert response page. The alert response page is a page built off the back of monitors. You can think of it as the alert page. And this has some core information on it. Now, unfortunately for me, this issue's actually resolved itself, so please forgive me, but this is a pretty good example of actually a full end-to-end visibility example where we have ID, trigger, alert duration. We've got what it's triggering off. So this is actually based on log data. So where my example was showing latency for the coffee app using metrics, we could also do the same for coffee preparation, but using log data. So the log data here, it actually logs how long it takes for these requests to take, and we can take that data into Sumo Logic and pass it. So it works out the latency and then works it out in seconds. So it's actually saying it's taking 1.5 seconds to respond, and that's bad, which basically means people are getting very quick coffee, and I can see why they're angry. So what we get is we get a lovely diagram showing us the problem here. So we can see at around 11:59 a.m. today, going into 12 p.m., that suddenly we had a spike in response times. The latency went up, and then we can see it come back down because that's when it got resolved. And this has and this is using the recovery function. So the actual issue, the alert resolved itself, so it no longer remains as open in Sumo Logic for you to see. So on here we have different cards. These can be referred to as context cards or just cards or areas of the page. The first one is obviously that triggered query information. The second one is log messages. These are messages that are appropriate for that time period, for that particular service or that particular log that you're using for your monitor. So we can see all of them here, and we can go through them manually if we want. But there's a bit that we provide something a bit better than that. You don't want to be just trawling through logs. You could just use log search for that. So let's scroll down a wee bit further. So we have alert context. Alert context is kind of like a bit of an machine learning AI tool, but it utilizes our log reduce function, which is really useful for making sense of logs. So the log reduce function, if you've never used it before, basically will get a load of log data that you've returned in a search and filter it by kind of unique signatures to those logs. So it will look for signatures which have changed. It won't necessarily, if you're just using it in log search, look for ones that have changed. That's where this actual function comes in. But it then groups them by similar signatures. So you're not looking through thousands of logs, you're looking through potentially 10 unique signatures. And for this one, we have 5 signatures that it's found in our log messages. So you've got, but then they're defined as new, missing, or changed. So just to cover what these mean, new means these are new, it's a new type of signature that's appeared in your logs since, but during this problem. Missing is you used to get these messages, but we're not seeing this signature anymore now this issue's going on. And changed is obviously these particular signatures have changed since you've been using it. So let's just take a quick look at this. And immediately what jumps out to me here is this first new one, and that is an error. So rather than being an info or anything, it's an error call, and it's saying that the thread is stuck in my kernel for 1,000 seconds. That's quite a long time. That's quite a long time. So something's going on with my system. So how can I investigate this further? What other information can I use? So that's where that playbook comes in. So on the top right here, we've got refresh, so I can refresh my entire page. I can then click on playbooks, and this gives me the playbook section. So this is where that admin has dutifully written out the steps for me to perform in the event that this alert goes off. And the first is to assess the impact on the service level objectives dashboard for the web front end. The second is to isolate the service that has latency, so figure out which of our services is the problem. Three, identify the root cause, which hopefully we can do through this dashboard. And then once we've identified that root cause, then we can go and resolve the issue. So let's take a look at the top-down observability dashboard for the time period that this alert was going off. And here's our lovely dashboard. We have a business overview, which represents like how well our revenue is doing. Now, this data can be got through logs or metrics, for instance. If you log that kind of information, Sumo Logic can do wonders with it. And then we have our max preparation time. How long is it taking us to our coffee machine to make the coffees? And up here we have our spike. Now, it's not necessarily impacting revenue. That's good. So people don't mind waiting 1.5 seconds, but we should probably jump on this anyway. So along here, we then have application services. So what's our front end? What's our coffee machine doing? And we can see there is actually a clear spike here, and that does correlate with our time. 11:55, 12:32. Yeah, that is 32. And you can see it's something going on. So it's taking our pages a long time to load. One thing to note here is if you look at all of the graphs on here, so this graph, and this graph, if I hover my cursor over one of them, you see a line moves on all of the graphs, which allows you to easily make sense of the data. So no matter where you are, I don't have to do the same thing. I can figure out instantly where the time is. So if I want to figure out what was going on at this spike here, I can then see it on the Kubernetes infrastructure section just below. Just note, something's going on with my CPU usage. So is it quite saturated then? So yes. So we jump to 100% usage for CPU. It looks like that pod probably falls over at that point, which is going to result in more saturation for the other pods, increasing CPU usage. So, okay, now I know that. What are my next steps? Restart that particular node. So let's figure out what node it is. IP10, so I can find out the node from this dashboard. Now, I could have taken this further. We could have gone into log search and stuff, but the dashboard I've got in front of me has given me all of the information to basically solve my problem. I've been using Sumo Logic. We've detected the issue quickly. We've then used our playbooks to investigate and isolate the issue, and then we've got the steps to resolve the issue, basically reducing MTTD, MTTI, and MTTR, which is effectively going to improve your customer experience and save your company money, because the longer you spend on critical incidents or even minor incidents and pull people out of rooms and start war rooms, that's effectively spending money because they're not doing their other jobs. So the quicker you can get these issues resolved, the better. There are other screens that are really useful, by the way. I'm just going to cover a couple of them. I am conscious of time. I have spoken for a bit longer than I practiced for. But if we nip over to observability here, we've got our metric search, our all metric searches. We've got Kubernetes and AWS observability. If you are using AWS as your system, the AWS observability stuff is brilliant. It's a load of apps that we have that come together, and they've got a load of dashboards. And there's also a bunch of separate ones you can install using our app catalog as well. We then have our application monitoring, which is utilizing tracing, metrics, and logs all together. And we have that breakdown into applications and span analytics. And if you are fortunate to use our RUM, you can get that full end-to-end visibility using our observability tool here. So let's just take a look at some of the dashboards. I'm actually going to nip to a services one because I like them. So let's go check out one of our services. Let's go to bar. And then what we're going to do is we're going to delve into the bar dashboard. So I'm going to open that in entity dashboard. So from the right-hand side here, it's going to load up a load of details associated with my bar service. I've got, say, for instance, 10 pods. We've got 5 deployments, 5 related services. So as you can see, this is running in Kubernetes. If I open this and go to entity dashboard, we get a lovely little dashboard, which gives us kind of all of those kind of 4 golden signals for our service here. So once that latency, it's spiking right now. That's brilliant. And we have a little service map which defines our services. We've got error percentages. So all of the things that we're doing here are here. And also what you can do is if you don't know how to build a search, or if you're really struggling to find that metric or struggling to find that thing, these pre-built dashboards do allow you to go in and see how that's built. So I can pop in here and I can see how that works. Which you can then rip and move into your own custom dashboards if you see fit. Anyway, so I don't start talking for the next 50 minutes. I probably do need to save some time for Q&A. Thank you everybody for listening to me. It's been an absolute pleasure. Let's just nip back over here and I'll slideshow it again and we'll come to the Q&A. Thank you.